Hello grade 8. Our lesson for today talk about the set of irrational numbers. The set of irrational numbers Q dash. Unit 1, lesson 2 in algebra. Okay? To understand the set of irrational numbers, and first I will make quick revision to remember the sets which we have studied before. The first one, counting numbers. Counting numbers is a set of elements 1, 2, 3, 4, and so on. And we use it in counting. Okay? The second one, natural numbers. Natural numbers is a set of elements starting with 0, 1, 2, 3. So natural number, capital N, is a set of elements 0, 1, 2, 3, and so on. The third one, integers number. The capital integers number. Integers numbers is Z, negative union. Set of 0, union Z, positive. Z negative like what? Like negative 1, negative 2, negative 3, and so on. And Z positive like 1, 2, 3, 4, and so on. So integers number like this set. Fourth one is rational numbers. Rational numbers. Q, rational numbers, is a set number that can be written in the form A over P. A over P. Any number that can be written in the form A over P, where A and P integers number, A and P integers number, and P not equal to 0. This set is called what? Rational numbers. Rational numbers. And it is denoted by capital Q. Q. Okay. So, remember with me, all integers numbers are rational numbers. For example, 3, negative 1, and 12. Here, 3 is integer number. We can write it in the form A over P because we can write it 3 over 1. Negative 1 equals negative 1 over 1 also. And 12 equals 12 over 1. So, all integers are rational numbers, okay? All decimals are rational numbers. For example, here 2.5. 2.5 equals also 25 over 10. 25 over 10. So 2.5, I can write it in the form A over P. So all decimals are rational numbers, and all percentages are rational numbers. All percentages are rational numbers. For example, here 15%. 15%. You can write in the form A over P, which is a second term, equals 100 because it's percentage, okay? So 15% equals 15 over 100, and you can simplify it, okay? All square root of perfect rational numbers, is a rational number. For example, here, root 36. 36 is perfect square. So root 36 equals 6. And root 4 over 25 equals 2 over 5. So all square root of perfect rational numbers is a rational numbers. And also, all cube root of perfect cube rational numbers is what? Is rational numbers. Like what? For example, cube root 8. Cube root 8 equals 2. Because what? Because 8 is perfect cube. So cube root of 8 equals 2. And also cube root cube root negative 64. Negative 64 equals negative 4 because I said The cube root for negative number is negative number. So cube root of negative 64 equals negative 4 is also rational numbers. Now, irrational numbers denoted by the symbol Q dash. Irrational number denoted by the symbol Q dash. And irrational numbers is what? The square root of rational number which is not perfect square is not irrational numbers. For example, like here, root 2. 2 here is not perfect square. So root 2 equals root 2. And root 2 not belong to what? Not belong to rational number. So root 2 here belong to Q dash, to irrational numbers. Also, the cube root of rational numbers which is not perfect cube is not rational number. For example, cube root 4. 4 here is not perfect cube. Perfect cube like 8, 64, okay, like 27 is called perfect cube. But 4 here, perfect square, not perfect cube. So the cube root for 4 not belong to rational numbers. So cube root 4 belong to Q dash, okay? The third one, pi. Pi is not rational numbers. Okay, Miss Sarah, pi equals 22/7 and 3.14. Strong. Pi, its approximately value is 22/7 and 3.14. It's approximately value only. So 22/7 and 3.142 are rational numbers. But each of them represented an approximating value of pi. Approximating value, okay, of pi, not equal to pi. So pi is a famous irrational number, okay? Pi is a famous irrational numbers. From the previous, we know something. Q intersect Q dash equals 5. Rational numbers intersect with irrational numbers equals 5. It's because there is no common elements between the two sets here, okay? There is no common elements between the two sets here. Now, please attention. Pay attention here. Root 2 raised to power 2. Again, root 2 raised to power 2 equals root 2 times root 2. Okay? For example, root A times root A. For example, root 2 power 2 or raised to power 2 equals root 2 times root 2. Here, the same idea, cube root A raised to power 3 equals cube root A times cube root A times cube root A, okay? For example, cube root negative 7 raised to power 3 equals, yes, cube root negative 7 times cube root negative 7 times cube root negative 7. Now, example, complete using one of the samples Q or Q dash, okay? Rational number or irrational numbers. Here, the first one, 3, belong to what? Q or Q dash. 3, Miss Sarah. Yes, 3 is integers number, and I said all integers number are rational number. So 3 belong to Q. Root 9 belong to Q or Q dash. Q root 9 equals 3 is perfect square. Root 9 equals 3 and 3 belong to Q. Excellent. Here, root 3 root 3. Root 3 is not perfect square. So, square root for 3 belong to Q dash. Negative 8 is integers number, so belong to Q. Cube root 5. 5 is perfect cube? No. So, cube root for 5 belong to Q dash, okay? Here, cube root negative 9. Also the same idea, negative 9 is perfect cube? No, because, therefore, cube root negative 9 belong to Q dash also. Here, negative 8, it's perfect cube. So, the cube root of negative 8 belong to Q dash because because cube root negative 8 equals negative 2. It's perfect cube. So, cube root 3, cube root negative 8 belong to Q, okay? Now, find the solution set in Q dash. Take care here. Solution set in Q dash for each of the following. The first equation here, 2x power 3 negative 7 equals 3. I need now to solve this equation. So I will separate between the variable and constant, okay? So I will move negative 7 to other side with the opposite sign. So we get 2x power 3 equals 7 plus 3. Simplify it, we get 2x power 3 equals 10. Then I will divide both sides in this equation by 2. So x power 3 equals 10 divided by 2. Simplify it, we get x power 3 equals 5. By taking the cube root for both sides here, we get x equals what? Excellent! Cube root 5. Cube root 5. So, solution set in Q dash. This number belongs to Q dash. So, the solution set equals set of element cube root 5. Okay? Clear. The second one, half x power 2 minus 5 equals 3. The same idea. I need to separate between the variable and the constant. So I will move the constant, negative 5, to the other side with the opposite sign. Here, negative 5, the opposite sign is positive 5. So, half x power 2 equals 5, not negative 5, 5 plus 3. So, half x power 2 equals 8. Excellent. So, I will divide both sides here by half. We get x power 2 equals 8 divided half. So, x power 2 equals 16. Okay, 16. Now, I will take the square root for the both sides here. We get x equals square root 16 equals what? Excellent. Positive or negative 4. Positive or negative 4. Or you can write it x equals positive or negative root 16. Positive or negative root 16 equals positive or negative 4. Now, this number 4 and negative 4 belong to Q dash? No, belong to Q. So the solution set here equals 5 because I find the solution set in Q. Okay, so the solution set is 5. Another idea here. Find two consecutive integers such that root root 13 lies between them, okay? Two consecutive integers such that root 13 lies between them, so I will think about two perfect square. I think about two perfect square, which number 13 lies between them. So the perfect squares is what? 1, 4, 9, then 16, okay, 16, 25, 36. So 13, number 13 lies between two perfect squares, 9 and 16, okay? So the square root 13 greater than root 9 and less than root 16, okay? We can simplify it. We get root 13 greater than 3 because root 9 equals 3 and root 16 equals 4. So root 13 greater than 3 and less than 4. So I cancelled. The value of root 13 equals what? Equals 3 plus a decimal number less than 1. So root 13 approximately equals 3 plus decimal number less than 1. Decimal number less than 1, I mean 0.1, 0.2, 0.3 and so on to reach 0.9. So root 13 approximately equals value between 3.1 and 3.9. So I will check all of them or some of them, okay, to reach the value of root 13. So the first one, 3.1 squared equals, with the calculator, equal 9.61. Also, 3.2 squared equals 10.24. Okay. 3.3 squared equals 10.89. Now, until now, I not reach to 13, okay? So I will check the other. 3.4 squared equals 11.56. 3.5 squared equals 12.25 and 3.6 squared equals 12.96. 3.7 squared equals 13.69. Oh, take care here. 3.6 squared equals 12.96 and 13.7 squared equals 13.69. Two consecutive numbers here. So I cancelled 13 greater than 12.69 and less than 13.69 by taking the square root for all sides here. We get root 13 greater than 3.6 and less than 3.7, okay? Another idea. Now, prove that root 7 lies between 2.6 and 2.7, okay? Root 7 lies between 2.6 and 2.7. Now, I need to find the square root of root 7 and 2.6 and 2.7. So, root 7 raised to power 2 equals 7 because I said before root 7 times root 7 equals 7. 2.6 raised to power 2 equals 6.67 and 2.7 raised to power 2 equals 7.29. Now we know something. 7 lies between 6.67 and 7.27. So 7 greater than 6.67 and less than 7.29. By taking the square root for all sides here, we get root 7 greater than 2.6 and less than 2.7. So root 7 lies between 2.6 and 2.7. Okay? I'm finished. Thank you for your listening. Goodbye.